All right, guys, sorry for the delay. We are here. It's 1/4 after, 15 minutes late. Apologies for that. Had a few technical difficulties, but we're going to try and kick things off here. Tonight, we're going to talk about Ethereum. Usually we talk about Bitcoin, but there are lots of other really interesting projects that have to do with cryptocurrency and stuff that's not even related to currency. I think Ethereum is one of the most preeminent blockchain technologies other than Bitcoin to capture the imagination of the world. It's especially come on strong lately, and it's we're really lucky to have Viktor Trón with us, Ethereum expert that can answer all of our questions. I think do you have a little bit of a presentation prepared for us? Okay, I'm going to try and share or give you control of the presentation so that the people at home can see what you're talking about, and then you can take it away. Just a moment here.
So shall I do a screen share?
Yep, there you go. You're yeah, I think if you go back to the control where you've got the Hangout open and go over to the left. Yeah, that green. It's just there. No. Here, click on that. There, click on that green box there. Okay, and share. There you go.
Usually,
there you go. Okay, so now the people at home should be seeing your screen and the stuff that we're seeing up.
Fantastic. Okay. So now we got through the technical hurdles apparently. So so yeah, let's talk about Ethereum. So first of all, because you're all coming from the Bitcoin world and used to kind of altcoins, talk about altcoins, let me start with saying that Ethereum is not really an altcoin in the same sense that most altcoins I talk about, because when we talk about altcoins, it's usually the idea is that it's something like Bitcoin, it's a cryptocurrency, and something in the protocol is changed, maybe shorter block time or a different proof of work algorithm, like in the case of Litecoin. In that sense, like Ethereum is completely different. It's a very different idea, which is somewhat related to Bitcoin in the sense that it's also based on the blockchain technology which underlies Bitcoin. But what does it do? It basically generalizes the whole idea of blockchain, which gives us a whole new perspective. It's basically gives us a world computer which does trustless computation that is secured by the decentralized consensus mechanism that underlies Bitcoin. So Ethereum is basically a decentralized application platform where you can do a lot of really cool things. And let's go into a bit of the history of Ethereum. So it was conceived by Vitalik Buterin, prodigy child, Ukrainian guy who was like 19 when he wrote the Ethereum white paper. He was working in the Bitcoin kind of Bitcoin sphere, and he was writing articles on Bitcoin and various applications. And when he was traveling the world, he started to encounter kind of somewhat innovative projects which went beyond the use of Bitcoin as a cryptocurrency in kind of merchant services. Were projects like Mastercoin and Namecoin, and projects which try to use the Bitcoin ledger or the kind of blockchain system underlying Bitcoin to various other purposes than just currency. Basically peg property rights, like do kind of smart property, record this stuff on the blockchain. And he was, when he was thinking about this, he came up with this idea that basically the Bitcoin instruction set, that's called the Bitcoin script, could be generalized into a fully fledged programming language, and thereby it would allow the blockchain to be used as a decentralized security mechanism to secure computation of arbitrary complexity. And he started to work on this idea and worked out a way to get around the most sophisticated problem with this whole scenario. What's the problem with this? The most obvious problem is related to the so-called halting problem.
The halting problem?
The halting problem. The halting problem is the following. You cannot tell, if you have an algorithm or a piece of code, you cannot tell whether the execution of that algorithm will ever terminate or not.
Will ever terminate or not?
Yes, that's the halting problem. It's basically a class of a complexity class of algorithms which is included in the Turing complete programming languages. So most languages that we use today, they are Turing complete. So you can write algorithms which you can never tell whether they terminate or not. And the problem with that is that if you allow such a complexity class to be executed on a blockchain, then you can basically stall the whole system. You can basically upload an infinite loop or any kind of complex calculation, which then would stifle the network. And the genius idea is that if you introduce real-time accounting into your calculation, then you basically have a Turing completeness in theory, but you have a resource boundedness in practice. What does that mean? It basically means that the node which runs the virtual machine, which does the computation, when it executes this algorithm or this script, for every single operation that the virtual machine executes, it takes some money out of your pocket. So you can basically execute script of any complexity as long as you have the money and resources for it.
So can I just reiterate for a second, just to see, make sure I understand and maybe see if we're all following along. So Ethereum is a decentralized computing platform, right? Turing complete computing platform that runs out in the wild just like Bitcoin does, right?
Yes.
And however, with any Turing complete language, you can write an infinite loop.
Yes.
And if you've got a decentralized system that's capable of running infinite loops, then it will be stalled by such executions, unless you have the resource bound in the form of a currency, which is the genius. Is that correct?
Yes, that's correct. That's correct. I'm going to talk about a little bit more in detail about this. It's just this was kind of historical introduction, how he got to the idea of the white paper.
Okay.
And so the white paper pretty much spelled out this idea, and he presented it in the Miami Bitcoin conference late 2013. That was less than 2 years ago, or actually a little bit more than 2 years ago, sorry. And how far did we get since then? My God. So the idea was pretty well received and already generated a lot of attention right on the start. And so that was basically when the Ethereum was founded, and Vitalik teamed up with C++ game developer Gavin Wood and Go developer Jeffrey Wilke, and they started developing the actual clients, the actual implementations of this idea. Of course, the the implementations had to follow some sort of common structure. So there was early on a very clear need that Ethereum should be specified as a protocol. And this was a very, very strong ideological guideline from the very start, that we wanted to be an implementation neutral protocol, so that it kind of protects the networks from failures that result from oversight just due to the particular implementation of the system. So Gavin Wood set out to write up the formal specification of the system that was more or less formalized, but in a kind of much higher level in the white paper. And this formalized version he called the yellow paper. And since then, the yellow paper is basically the Bible for all of us. And I met Gavin in January 2014 in a CoinScrum meetup in London. And that was a very, very early stages in Ethereum, and he was basically the only C++ developer. I kind of dabbled into the code a little bit already, and found the idea fascinating. But in all honesty, I didn't really trust that it can be pulled off. It seemed to be like a really outlandish idea and very, very brave. And the more I spent the time with these guys, the more I realized that they are absolutely genius. And I kind of helped Gavin review the yellow paper. And once I kind of really worked my way through the math, I had to realize that it does work, and it really stands perfectly. And that's when I decided to join the effort. And at that time, obviously, I was just working for free and as just a contributor to this open source project. And at that time was when the Ethereum Foundation was trying to sort out how development should be funded. The founders found a way to basically monetize the project. They came up with this idea of the Ether pre-sale. So the idea was that Ethereum, the network will have obviously this underlying currency. It's similar to Bitcoin. We're going to talk about it in more detail. And the idea was that people can buy into this Ether, like basically buy the future option. So they are entitled to the Ether when the production ready live network is done and released. And for that promise, basically they pay in some Bitcoins. And the total amount of Ether that they buy will basically be the total issuance of the currency, the initial issuance of the currency. And this was very, very successful. So it seemed to be that obviously at that time there was already pretty the blockchain Bitcoin technology was pretty hyped. So there was a lot of speculators who were interested in investing in this field, and we managed to pull off basically the third biggest crowd sale ever, raising Bitcoin equivalent of $18 million, and that's happened in summer 2014, and that's when the development really started in earnest, and that's where developers started to be recruited, and that's where I also started to get a salary and be officially on the payroll of the Ethereum Foundation.
Did that $18 million affect the value of Bitcoin? If $18 million was bought at Bitcoin value, that people were purchasing it in Bitcoin?
Well, no, they already had the Bitcoin. They just
spent it.
they transferred it to the possession of the Ethereum Foundation. Actually, there was a problem so the fact that it was not affecting the price exactly because the Ethereum Foundation kept the bitcoins, which it was accused of this blunder quite often since then, because at that time of the transfer, the value of Bitcoin was quite high, and it went down. So we lost quite a bit of the value of this pre-sale amount.
But the price went up, so actually you were still plus, right?
So the problem is that by the time we could capitalize on like, we had to pay a lot of expenses in fiat currencies, right? And at the time we could pay it in fiat. At the time the Bitcoin price was quite low. So basically, let's put it that way. We could have made a lot more value out of this.
But how many Ethers were exist and how many were offered? Where is the rest?
I'm sorry, I don't have the numbers exactly. Sorry, I could look it up, but the exact number doesn't really matter after all. It's
it matters a lot. So like, because I know we are still in proof of work.
Yes.
Yes. So from what I know, it will be initially proof of work, and then you go to proof.
No, not really. It is proof of work right now, and the mining reward is 5 Ether. Yeah. So it's similar to Bitcoin. There's a constant new issuance. Therefore, there's also controlled inflation the same way as you have in Bitcoin. So after the pre-sale, development started to happen. We opened offices in Berlin, London, Amsterdam, and Switzerland, and the first developers conference, the DEFCON 0, took place in December 2014 in Berlin, where 40 developers gathered, and all the development efforts led to the actual launch of the Frontier Live Network. The Frontier Live Network was the first time when Ether actually had value, so to say, because it was tradable. It was the proper currency of an actual network, there's a lot of development that happened since then, leading up to the very successful DEFCON 1, which took place in London just this autumn, and it had like 400 developers taking part. There was Microsoft announcing the use of Ethereum blockchain on their Azure cloud. There were banks. There were a lot of really big shots taking part. So you can see some photos of some of the early days, and you can see on the second row you see Vitalik, Jeffrey, and Gav hacking together, and the bottom row you can see the developers, the core developers in 2015, just this autumn. The funny logo is actually a combination of Microsoft and Ethereum that is mocked up to mark the occasion when Microsoft announced the blockchain as a service, the Ethereum blockchain on their Azure cloud. So anyway, there was the Frontier release, and you can see the development roadmap of Ethereum. So we have several stages of the development. So Frontier is still what's going on right now. This is the network which we call the Wild West, because it's really directed only towards developers. We only promise a command line client. It's pretty geeky to handle that. We never said that your grandma can handle anything. So we were quite cautious from the start. But obviously we're targeting kind of less tech-savvy audience as well, but just only with time. So the Homestead release is the next stage, where we are kind of planning to cross off the unsafe attribute from our network, and this is coming hopefully this quarter. And this as well, the Homestead, we will see the release of the light client. Light client means that it's going to be a client which does not need to fully synchronize and download the whole blockchain. So it allows for mobile applications to run smoothly with the network. It's basically similar to the simple payment verification protocol in Bitcoin. It's kind of similar idea, very different implementation.
What is that protocol? It just allows you to cache just relevant.
It's basically like so. If you really understand the Bitcoin protocol is meant to be a completely trustless protocol, which means that you don't have to know and trust anyone. Just join the network, and you can verify the system state by basically downloading the blockchain all the way to the Genesis block, and verify that the current state is the longest chain indeed, and verify every single transition of the state, and so therefore you don't need to trust anyone. With the light client protocols of simple payment verification, you have some sort of checkpoint or some sort of some way where you break this complete trustlessness.
Yeah.
You have to trust something, at least someone, some node, some historical point in time, and also have ways to not verify. Maybe in the case of Ethereum, not necessarily verify all the transactions that come in.
Can you give us an idea of like what the capabilities of a light client would be? Like what kind of things you're able to do?
So the light client is nothing else. It's just basically does partial verification of the state, and
but what can it be used for? I guess
it saves a lot of network traffic and disk space.
Okay.
Computation. So basically, mobile apps can use that as a lighter
so
version.
a mobile app running on the light client.
Yeah, but the light client also provides levels of security. Obviously, it also can verify your own accounts, the transactions that are relevant to you. Some partially the accounts, but it does not verify everything, and certainly does not verify it historically all the way down to the Genesis block.
Let's check that the light client would provide an access point for any other applications that want to use Ethereum on that device. So you wouldn't run everything on the light client, the application light client, but it would become like a kind of a subsystem that other apps, mobile apps, would use.
On the same client, yes. So the idea is that if you have like a wallet app and I don't know a decentralized Facebook app on a mobile, then they would communicate with the same backend light client.
Awesome. Yeah, right. So it becomes kind of like
that's the whole idea.
Yeah.
So Metropolis is the next stage, which we don't really know what exactly it is. It's usually said that it's marked by the release of the Mist deb browser. I will talk about that later, what it actually is. And the major milestone that we're targeting is called Serenity. That's when we're planning to switch over to proof of stake. I will talk about the details of how proof of work works and what proof of stake is later. So these are the main stages, and of course the timeline or the expected time of Serenity is unknown at this moment, because Casper is still pretty much under research and development. Okay, so yes, and the research, which sometimes scares the shit out of me, because with Ethereum at the moment is pretty stable, and there's a lot of applications being developed on it. So the thought that we're gonna switch to something that's not proven to be very safe is actually quite a scary thought. Even though it's the brightest minds that work on it, and it's really making amazing progress.
But Gavin Wood is no longer part of the.
No, Gavin is not. Gavin was never really working on the proof of stake anyway. He was working on other stuff.
But that's scary. Like, it's even more pronounced than
Mike Hearn
left Bitcoin.
I mean, Gavin didn't leave the Ethereum world. He just left the foundation. He's not on the payroll of. Actually he's on the payroll as an advisor, but he's not leading the C++ team and doesn't work on the client anymore. He's going to do his own private business, I guess. So this is just a quick, nice graphics showing the Frontier Live network monitor. You can see like some of the registered nodes there. You can see the current difficulty of the network. You can see how much time elapsed since the last block was found, etc., etc.
How big is the blockchain? Can you see here?
In terms of what it's like, the number of blocks is almost 1 million.
I mean the blockchain, like size.
The size is, I think, about 6 gigabytes right now.
6 gigabytes. That's a lot.
Yeah, it's a lot. I mean, it's not only blocks actually. So it's a little bit more complicated with Ethereum. I will talk about this in detail. Maybe I should go into it right now. So what are the components of the Ethereum network actually? So it's obviously there's a secure peer-to-peer networking layer, very similar to Bitcoin. In like for non-technical people, at least. I mean, in technical ways, it's very different actually. But for all intents and purposes, just think of it as the Bitcoin network itself. So you have nodes communicating with each other and passing messages, broadcasting transactions, and trying to negotiate blocks. What's more important is the first line. Basically what runs in a node is a virtual machine. Virtual machine is executing these scripts. The scripts are bytecodes of the Turing complete language. So they contain like computational operations, and the virtual machine executes them. On each and every single node, execution is identical, needs to be identical. So for example, there's obviously in this programming language, there's no system codes like what's the time and things like that, because it has to be exactly the same everywhere. So there's no external. So for example, there's no hardware-specific random numbers generation either, because that's obviously wouldn't be the same on each and every machine. So it has to.
What if you even do upgrades and everything's not simultaneously going up with the same upgrade? You're saying the code's the same on every single node across the network?
No, I mean the virtual machine specification is exactly the same on each node. It has to be. So there could be upgrade in the code which influences, I don't know, maybe execution efficiency, but the virtual machine specification has to be exactly the same. So
you're going to upgrade that sometimes, or is there
I mean, there might be changes, but in that case, it's kind of similar to the Bitcoin hard fork situation. So because everything that requires a protocol difference, which would lead to different blocks, or which would lead to a situation where different nodes accept different blocks as valid, or the same block would be valid on one node and the other. That constitutes a hard fork situation.
As long as you tag which version of the protocol you're using,
Yeah.
these things are not a problem. Because then you say, ah, I need to switch to this version of the protocol.
I mean, but switching to a different version of the protocol means a hard fork.
Yeah.
Don't forget that. Okay, so anyway, so basically there's a virtual machine running on each node, and as the virtual machine executes the operations, it does this real-time accounting. So basically, calculates for each and every operation an amount of gas that the execution, that the computation is costs. The gas works pretty much like fuel, in the sense that it's a commodity that's priced on the free market, priced by the miners, who decide how many ether a unit of gas costs. And a unit of gas is what how the operations are accounting the execution cost.
Sorry. So
Yes.
if 100 nodes process my code,
Yes. They will process
I
it
will
at
pay to everyone, or the one who wins the block, I will pay.
Yes, exactly. Just the one that mines the block.
Okay.
The one, so it's in the sense it's the same as the Bitcoin
So
network. So the
everyone-
miner bags the transaction fee in the same way here as well. But here there's not only transaction
So
fee,
I
but also
pay-
execution fee.
I pay after the block is done. So all the nodes process my code, and they calculate, let's say, 1 million gas units.
Yes,
Your code cost us 1 million gas units. So
Correct.
I have to pay this 1 million to the miner who makes the block.
correct. So when you actually accept the block, that's when you take all the execution fees and credit it to the miner's account.
But
And
what's
when I'm a miner, I'm accepting the block that you submitted. I'm also accepting that accreditation of that transaction fee to your account, to the miner's account.
Yes.
Clear?
What stops me to create a code which is infinite loop and then send it to the miners to process forever, and then in the end I don't pay, because they don't charge me.
No, but wait a second. I
This
mean,
was
they constantly, so when the virtual machine runs and executes each operation, they look at your wallet, they look at your account and actually see whether you have the funds. You understand? So
Big overhead, isn't it?
so that part is taken care of at the time of the execution. It's only at the time of validation of the block where this kind of minus generated cost is credited to the miner's account. Yeah, got it? Okay, so that's actually so mining is not only transaction processing in the simple sense as in Bitcoin, but also like the virtual machine code execution for each and every transaction. I will tell you how this works. So when we say Ethereum blockchain, what we actually mean is not only the blockchain, where strictly speaking by blockchain we mean the packaged set of transactions one after the other chained, but here it's also a separate database of system state, where system state is all the accounts with their account storage. So Ethereum blockchain acts as a proper database of that has arbitrary data, and in the code which executes, you can have storage directives. You can basically have permanent storage, which you also pay a certain amount of gas for. Is that clear, more or less?
One thing I'm not clear about is if I want something to execute,
Yes.
why would I'm confused about this? Say 1,000 people compete for that. They all execute it, and then the winner. I don't understand that. What's the efficiency of that?
The it's not meant to be efficient.
It's not meant to be efficient.
It's meant to be efficient in the sense of efficiently providing you security, which is decentralized consensus.
Right.
Efficiency in the sense of doing away with the requirement of trusting someone and a third party. It's not meant to be an efficient computation system in the sense of distributed parallel computing. It's just the opposite.
Yes.
In fact, the efficiency of the virtual machine is like the mobile phone of the mid-90s or something. It's really not efficient in terms of computation. But it's not a problem because we don't really want hard computations to be executed on the blockchain. It's only to record stuff and verify stuff that's of public concern and has to do with transparency that we need to secure in a decentralized way.
So this is not a generalized parallel supercomputer.
Not at all. Not at all.
It's only about trust.
It's actually the opposite because it's meant to be inefficient in the sense of every node that participates in the network computes the same stuff over and over again.
Yeah.
So so the more nodes you have in the network, the less efficient it is, so to say, because overall the overall computation.
If I switch on a host now on my computer, does it mean that in order to process the whole blockchain, I have to make all those computations?
Yes. If you're an archive of full node, then you have to do that exactly.
All computations.
So the state is each step in the state is remembered.
Can be remembered, yeah. I mean, in practice, the specification of the protocol does not make you remember every single step. Only the outcome of one transaction, but even that is not necessarily needed. What you really need to remember is the state after each block, because that's how the system works. So once again, Ethereum is a generalized state transition system, where system state is kind of an arbitrary database, and so let's compare it with Bitcoin. So with Bitcoin, it's the same. You can consider Bitcoin also a database, like a state system, but this database contains accounts with balances only. Or like, Bitcoin doesn't exactly work like this because it works like inputs and outputs, but it doesn't matter. Like on a conceptual level, you can think of it as just an Excel spreadsheet of account balance. And the transactions are nothing else but transfer transactions that transfer money from one row to the other. So this is generalized in Ethereum, and in Ethereum, the system state can be an arbitrarily complex database where each account has their own storage, permanent storage, and on the account, it's not a balance that sits, but on some accounts, there's a piece of code that sits. And that piece of code is called a smart contract or contract, and a transaction is nothing else but almost like a function call. It's basically when you send a transaction to an account, you say that please execute the code on that account with the data that I send you as input. It's almost like, let's say that an account is like an account is multiplication, like x multiplied by y, and the transaction has to send in the actual values for x and y. So it sends in 2 and 3, and the account execution, the VM, when it executes it actually multiplies 2 by 3 and comes up with 6 and puts that in storage or something. So this is basically how it works, except that the smart contracts obviously are doing much more clever things than just multiplying numbers. Oh, thank you. Because I'm gonna
Can you like big picture it for us though? What would you use this kind of?
Yeah, maybe I should.
Yeah, like.
I think we started on the wrong end, right?
What's an example of something that you would need such a computer for that you can't otherwise do?
You can't otherwise do.
Tracking property records?
Yes, so for example, first of all, you need to have an example application where it makes sense to have a decentralized consensus on some state. So, for example, a property record is a very, very good example, or any kind of notary system, which historically always justified concentration of power because, or the existence of state and government, because they were the keepers of the truth, so to say. Because there's in a lot of situations, there's no other real way to make sure there's consensus about the state of affairs other than monopoly of force. This was really almost like a necessity throughout history. And it's a major innovation with Bitcoin that such a consensus can be pulled off without a monopoly of force, just simply with the decentralized consensus mechanism. So let's think of a property record. The most obvious one in the digital world of property records is a DNS, is a domain name system.
DNS, yes.
So
Domain name
and
system.
and historically it's also very interesting because that's what Namecoin was already trying to do, and in earlier times, already in 2012 and 2013, and that was from the very start. Was kind of a signature application of Bitcoin, of Ethereum, where we realized that implementing Namecoin in Ethereum is one line of code. Because what do you have to do? You basically record the data sent in the transaction. You just record it in the blockchain as stored data. So what you do is like I send in from my account. I send in viktortrón.org, and what the system does is like looks at my account and says like, okay, so the owner of this name is Viktor Trón, is this account, and I register that name in the storage, and that's all it does.
Is it built in that it looks for conflicts? I mean, if that's already been registered.
Yes, okay. So it does. It first looks up whether that is taken or not.
Yeah.
And if I buy it from you, then that would be.
So there would be another line of code, obviously, to allow transfer. That would be another line of code. So
yeah.
But really the main point is that it's super easy to implement such an input. So it actually made it to the first DEFCON's T-shirts. On the back of the T-shirt, there was the Namecoin implementation.
Now, Bitcoin cannot do this, right? Bitcoin cannot track other pieces of information.
You can actually implement Namecoin in some sort of roundabout way, but it's not possible in the pure, because this actual scripts doesn't allow such an operation of storing arbitrary data, checking whether the data is owned by a certain account or not. So you have to do kind of some sort of juggling with that, and you need some external system as well to handle that feat. But with Ethereum, it's really the signature applications of such a system is really important.
So is this application right now?
Yes, there's already a name registry on the blockchain.
Are people using it seriously, or is it just proof?
No, at the moment nothing is really serious on Ethereum.
Yeah.
Sorry, some people might be offended by me saying this, but
that's things like if they're like voting. I mean, if everyone could vote and you have a reliable system, you didn't have to have polling booths. Is that what that means?
Yes-ish. The problem is, of course, is somewhere else. The problem is with the identity system. You cannot, just with the blockchain, you can never solve the problem of one vote, one person. Because you can only have one vote per account, but you can have any number of accounts. And so without some sort of reputation system or biometric identification or without some sort of system, you can never replicate a one vote, one person system. A lot of people working on ideas how to do that. Similarly to what you have, like, I don't know if you guys heard about the signing parties of when you do like key exchange, and so when people kind of prove or sign that they actually saw that this key belongs to you, and this is for example PGP and some of these private key registries use these kind of systems.
Is it trying to get away from I have an address, this is me, you know, because that's how governments actually
not necessarily not necessarily
Yeah.
you don't necessarily want to get away from it.
Yeah.
And of course Ethereum itself doesn't have an opinion on that, because it's a featureless system. You do whatever you want with that.
Sure.
And for a lot of applications, it makes sense to have some sort of one person, one account type of situation. But going back to your question, voting is not necessarily based on such a criterion. Only socially relevant voting. But there's a lot of situations when voting can be, for example, stake based. So you can have as much weight for your vote as many assets you possess, and that's very easy to justify. So, for example, if
How many Ethereum
yeah,
for example, so all the people could vote.
because then all your accounts just add up to this to the amount that you possess, and so that's the same thing.
So, thinking social conditioning, societal, is there a danger there that if we start going down the road of the more you have, the more weight you have, is that a philosophical dangerous place to be?
Depends on who you ask. I mean, I personally don't think that's necessarily a very bad system, to be honest.
And what you're using the voting for, like it's just a technology, right? You're saying this is one of the ways you could use it. It's not saying this would be the right thing to use across the board for everything. It's just saying that's one of the.
But there's many ways that people are thinking of like mitigating that problem.
Yeah.
So there's ways to link it to biometric data that may be the future way to solve this problem, or link them to kind of external and other sources, reputation systems and stuff. So there's many ways to counteract this. But anyway, so the whole history was I just wanted to mention that when Vitalik was trying to think about, like, when he first met these pioneer ideas that try to use the blockchain for something else than what it originally meant to be used for, like the currency. That's when the whole idea was conceived, that maybe we can generalize this and then just use it outside the strict realm of financial contracts, or like multi-sig wallets, or like basically money transfer. Use it for other things.
Because if I'm not mistaken, Satoshi Nakamoto has stated in his white paper that about all this scripting and functionality which you're talking about, he only said we cannot start with the whole idea because it will be very difficult for the idea to. That's why we start with the simplest, which is the currency, and then we can expand on this. So
I don't know how much he went into that, but I think it, so in this sense of, obviously the possibility of generalizing this idea was not new itself.
Yes.
But the way how to generalize it and actually coming up with the idea of the gas accounting and all the intricacies of how this system is put together was genuinely new. But yeah, I mean, obviously if Satoshi had never existed, never written Bitcoin, this would have not been a possible feat to found out by a 19-year-old guy. It's however smart he is.
okay, can I ask you about the financial derivatives, for example?
Yes.
Do you know, in order to solve a derivative, you need a price fit. You need to know the price of the security at the moment, at maturity. Who supplies this information to Ethereum? Can you, with this language, connect to a server and get the information. Is it
No,
possible?
no, it works the other way. So it also always has to be a price feed that is
Yes.
fed from the outside, because you can never do like API calls or something like, you know, you can never pull the data from within the contract, from within the code that executes the so the only way to do this is that you have a continuous feed, the correctness of which is guaranteed by some sort of reputation system. There's no other way to guarantee that, because you can always cheat. You can always cheat, like, because that's always an external source, and you can always mess with that. So the guarantee of that is not, that does not have the same level of security. Only maybe with time, if the system is very secure and you have a lot on the line, you have a lot to lose as an Oracle service. If you cheat and if you lie, you basically lose a lot of your, say you have a deposit and that.
So it's done with oracles.
It's done with oracles, exactly. But that's kind of good enough. It allows for pretty sophisticated systems, and so ultimately from the first seeds of ideas of like Namecoin, we got all the way to like whole voting systems, programmable democracies, programmable banks, and all kinds of Internet of Things applications that are, most of them are still in the kind of visionary and dream phase, but some of them already exist. For example, code for a remote unlockable door lock already exists. So that's pretty smooth.
And that's all within, because as I understand it, like I would have thought a lot of the functionality has to happen outside.
Yes, obviously the whole hardware and the whole controller systems have to be outside. Yeah. So what you end up having on the blockchain is almost like pretty trivial.
Yeah.
But the point is that it has a transparent interface, a transparent.
Do you know
control.
these banks are what was this pilot project 2 weeks ago? What it makes?
What
The R3 consortium, they launched the pilot.
R3, okay.
R3, yeah. Do you know what they did?
No, and they did nothing. What they're gonna do is also a bit of a mystery. And to be honest, I think that at this moment, no one's really sure. They jumped. I mean, if you ask me, I have the hunch that they pretty much just jumped on the hype train because they realized that this is big and they have to do something about it. And you know, I mean, there's some obvious applications that you can think of. So like interbank settlements of funds can be done in a very smooth way in a kind of consortium chain. Consortium chain means that it's basically a private network, but it's transparent and interoperable between the consortium members.
So what they launched on this Azure, is this part of the Ethereum network, or they just use the technology, they download it, and then it's a permission?
Yeah, I think it's a permission blockchain. That's why I call consortium chain. So that private shared by certain members of a consortium. But to be honest, like no one knows, because like these are not yet fully figured out. No, I don't think they might have done some sort of feasibility study or some sort of research into what they want to do, whether that's feasible or not. But I don't think they actually built anything yet.
Whatever code I publish on the Ethereum network, it's visible. It's public, right?
Yes. Although you don't necessarily have, because like don't forget that what sits on the account is bytecode, and good luck reading bytecode for the average person. And of course, bytecode can be it can be disassembled, so to say, in a way that's more or less understood. So nothing can be a big secret, that's so to say. So it can be reverse engineered based on their behavior, or also actually there's a lot of code analysis tools that can be disassembled.
There's no way for me, if I'm a genius guy and I say, oh, I will now make this decentralized application on Ethereum and make a lot of money out of it, it's not possible, because if I publish this application on Ethereum, everybody can just take it, copy, and launch it for free.
That's a very, very interesting fact about Ethereum, that's almost built into the system, at the heart of the system, that any kind of this middleman services that you can run, basically automatically driven to marginal cost, because of the near zero switching cost and the transparent and the open architecture.
But this is
anyone can substitute it with
not a replacement for commercial.
Actually, it's a little bit of a problem, because a lot of people are unsure what will be the business like what will monetize businesses and innovation. Because at the moment, this whole startup culture is, predicated on the fact that people expect big bucks. Like you can win. There's a small chance that you can really make good money. And if it's not the case here, because you can be very quickly disintermediated by a cheaper service with zero cost, and that's a bit of a problem. So we have to come up with, like, or dev developers have to come up with different business models. Either they keep a crucial part of the system proprietary, as in the case of, like, say, a door lock or some sort of hardware specific technology, or they base their revenue, they secure their revenue stream based on their brand, that people almost like as if you were a musician that's sponsored, that basically maybe the Ethereum Go team has a reputation that people will trust, like, oh, let these guys maintain the stuff, and I pay them the 50 cents that they need, even though their particular contribution could be done by a kind of cheaper service or something. But I want them to do this because I trust them. I know that if I need features, then they are the people who are capable of developing that. So it's kind of basically a brand-based business model.
Like the Linux Foundation is the same, so they get the money.
Okay, so all kinds of systems which based on donations, that's possible here. The problem is that kind of rent-based businesses are not really very easily possible. So, like, for example, I mean, let's go into this kind of application, which is much more interesting kind of than the technical details I'm talking about. I think they're probably not so interesting to you anyway. So I wanted to talk about the memory hard proof of work, but let's forget that. And I wanted to talk about the currency and the price feed, but it's not very interesting. Let's talk about the Ethereum ecosystem first. It's not only like several implementations of nodes, but there's also GUI browsers, which will allow these decentralized applications to act pretty much like the web applications of today. The infrastructure has IDEs, like integrated development environments, that allows developers to develop smart contracts and deploy them and test them. There's blockchain explorers, pretty much like in the Bitcoin infrastructure. There's exchanges which allow you to exchange Ether to Bitcoin, and also USD and Euro, and etc. And crucially, the part of the infrastructure is the dApps, the actual applications that already exist, some of which are listed here, and there's several listings on the internet of these ideas. Some of these are already online and pretty much working. For example, Augur. I don't know if you guys know. Augur is a prediction market where you can open any market, like a prediction market.
Platform.
You can call it branding, gambling. You can call it gambling. It's generalized betting. It's betting on predicting outcome of any event.
Yeah, sure.
Yeah. So for example, the Iowa caucus was, for example, a market as well.
So it's working now.
And it's amazing. It's actually almost completely accurate. I mean, these systems are pretty much the best prediction systems that exist, because they can figure in the knowledge of everyone, and people who are willing to bet are the ones that think they have the most knowledge about things. It's very, very interesting.
So are you saying that Augur is deployed and it had an answer for the Iowa caucus?
I think so.
And it was accurate?
Sorry, I didn't actually check the Iowa caucus, but the previous ones that worked very, very accurately. And so there's some other very interesting applications, like, for example, Maker is a very, very interesting one. For example, Maker implements, it's a very revolutionary idea. They implement a stable coin. And don't even start me on how they do it, because I don't understand. It's pretty complicated how they
A stable
coin.
Stable in value?
Yeah.
One that doesn't fluctuate.
Yes.
Or like Ether dollar, like they can.
It's, read about it, because I mean, honestly, if I tried to explain it to you, I would make so many mistakes that it would be embarrassing. So it's pretty complicated system how they back up a currency with another one and buy up the debt, like when it goes down. It's like very, very, very interesting how they do it. It's pretty revolutionary idea. And yes, so some of these steps are listed here, and some of the big names here. So I don't know, R3 was already mentioned by you, and R3 is a consortium of big banks like Bank of America. I think Deutsche Bank is like, I think 13 banks at the moment. You can see Microsoft Azure, and IBM and Samsung had an Internet of Things project called Adapt, which used Ethereum for the micropayment system and the contractual settlement of their prototype, which was about a washing machine that orders detergent and orders repair when it gets broken. It's very, very interesting.
Of course, because we can't.
Do you know about this Microsoft Azure and Consensus? Because I work with Azure.
Yeah, you do?
I found it.
You do? You're among the very few, I think, that not a lot of people use it.
Yeah, no, I don't know what does it give you. I didn't understand what to. You don't know, because it's a lot of.
It gives you a private chain.
It gives you a private chain.
Yeah, it gives you you can deploy your own blockchain with a click of a button. Very, very interesting. What private blockchains are good for is a good question. Again, if you want my honest opinion, I think Microsoft realizes that they are behind Google and AWS, so they had to jump on a hype train again. Like, they quickly saw that Ethereum can be a good buzzword for them. Sorry, I'm very cynical right now, but
it has been recorded.
Yeah, but it's wonderful, and it's great that they do it, and it's great stuff. But the real world value for me is at this moment a little bit questionable, which is also criticism of the technology that I'm developing in a way. Because
what are you working on?
What am I working on? I mean, historically, I worked on almost all parts of the core, except for the real core engine of the VM.
So you are working for the foundation?
Yeah, I work for. I am a core developer of the foundation on the Go team. I started the dev peer-to-peer networking system, but it was my colleague, the genius Felix Lange, who took it over, and for a good reason. I worked on various parts. At the moment, my work is mostly concentrated on Swarm, and I kind of wanted to talk a little bit about that if we still have time, because that's kind of interesting. So how the whole Ethereum idea of the blockchain basically got extended into a real ambitious vision of the next internet. So the idea is that Ethereum would be the backbone of the next internet, because that's what provides contractual settlements like all these notary and registry systems, financial transactions between people. But it can be augmented with, so to say, base layer services. For example, Swarm, which is the Ethereum's words on file storage and content distribution system. That's what I'm working on at the moment. And Whisper, which is an anonymous messaging system, or messaging not necessarily in the strict sense of like a chat, like a unicast peer-to-peer chatting system, but more like a Twitter-like system, basically an autonomous datagram service.
With message.
Yeah, basically message. Yeah, and so the idea is that on these three legs and a few others, you can pull off a whole new internet, which is serverless and completely decentralized. So it's not only that the interactions and contractual agreements are decentralized by Ethereum, but also the storage is decentralized. It's on this distributed system. We don't need to go into details like that. Just think about BitTorrent. It's basically almost the same idea in the big picture of things. It's basically our own BitTorrent
Like
similar system, a bit like MadeSafe.
What happens with them,
I don't.
Because
I don't. We're more in synergy with IPFS, which we will probably. I don't know if you heard of IPFS. It's also a bit like MadeSafe. IPFS is interplanetary file system, and that's also a clever distributed hash table implementation of file storage, and Swarm will probably be
your version.
We're going to collaborate in one way or other.
So you're working on Swarm.
And I'm working on Swarm at the moment, mostly. And so what else did I want to tell you? I wanted to tell you about the Mist browser, and I wanted to demo it to you.
Yes.
Because basically that's the first application which is supposed to be user-friendly, in the sense that at least mildly possible to use without deep technical knowledge of the command line. But this is only partially true, because in order to start it, you already need a bit of the command line wizardry. But with time, it's going to be perfectly usable GUI. And I don't know if you have internet and time and there's interest, I can go into a bit of demo. But
I vote for it.
Yeah.
Everybody's free to live, no problem.
What's Electron / Meteor?
So Electron is basically a browser, is a JavaScript browser implementation. Okay. You can have your own browser renderer. It's a renderer framework, and Meteor is just a JavaScript framework for web apps. And so this is the GUI. How the GUI is implemented?
Yeah.
And it communicates with the backend client, which is the Ethereum client through an IPC. IPC is just a communication protocol.
That would be the same way that the light client on
exactly
the
same way.
Cool. Awesome.
And can I ask you, because I see Bitcoin deposits, is it possible in Ethereum to make payments in the Bitcoin blockchain?
Actually, it's fantastic. There's a dev called BTC Relay, which actually does Bitcoin verification on Ethereum.
Verification, but not
Well, that's the same. Because you basically
who's gonna sign
you basically send in the transaction, and it verifies that it's a valid payment.
Okay. It's not the same. Anyway, sure.
But this refers to something else, right?
Yes,
This refers to a possibility to use this basically uses what's the Shapeshift? Is the name? This uses Shapeshift API to to do a Bitcoin payment and buy Ether for you to play with.
Oh,
So it's just it's nothing to do with the in Ethereum Bitcoin payments. Yeah. So that's pretty much it.
Yeah.
Guys, the thing is, I need to take medication. That's the problem. So because I started to shake. I need about 10 minutes of
If you want, let's make
Take a break. Take 10.
break.
Take a little break.
Anyone that have any even low bandwidth internet? They can,
Yes, you can use my mobile internet.
Yeah.
Tethering, if you want.
I can give you that.
yeah, great.
Oh, that's good.
Open my app.
Okay, so
It's 4G now.